Hey everyone, welcome back. In this lesson we're going to take a look at remote debugging. So here I am on the Nexus 5 landing page. There's the URL, and as you can see it's a nice page and it's got a bunch of snazzy effects. Now unsurprisingly, snazzy effects tend to work pretty well on desktop, but not so well on mobile devices. So we're going to utilize remote debugging to find out how we can discover such issues. First, I will right click and inspect element. So we got the DevTools up. And as you'll see in the top right corner I've got this little devices icon. It's telling me I've got one device found, so I'll click on it, and what's cool here is it's brought up this new devices pane. Now I should say that this is an experimental feature currently, but maybe when this course is released this will be promoted to stable. Before I continue, I'll just let you know how I actually got this working. I enabled devices from the experimental settings, and then I connected my Nexus 4 device via USB cable to my laptop. My device isn't rooted, however I did have to enable developer mode, and that's all documented on the Developer Tools Remote Debugging documentation. Finally, as mentioned in the intro, I'm using Chrome Canary, and on my device I'm using Chrome Beta for Android. So let's get to it. I'll click try here. And as you can see, a brand new DevTools window has actually opened up. Now here's what's actually happened. By clicking try here, it took the current page that I was on, in other words the Nexus landing page, and it opened that page on Chrome Beta for Android on my device. Now before making this lesson, I was figuring out how I can show you this. One option is to use a webcam to record the device, but I actually want to demonstrate another feature of DevTools, and at the same time use it to show off my device, and to do that I'm going to use a feature called screencasting. So in the top right corner I've got this little screencast icon, and I'm going to click it. And what continues to amaze me is this is an actual real-time preview of my device. Right now I'm scrolling it, and as you can see that's reflected in real time, which is really great. And I can also scroll the device here. And so scroll commands are actually sent directly to that web page from the DevTools, and you get this nice bi-directional communication between the two. One thing I do want you to take note is to do all that I didn't have to touch my device. Of course I touched it initially just to wake it up and also open up Chrome for Android, but apart from that, the opening of the page, the scrolling of the device and interacting with it, this is all done from DevTools. Here we've got a little drop down. You click it and some stuff opens up and you can close it again. Now if you're watching closely in the DOM tree view, that's on the right side right within the elements panel, you'll see a little attribute is being modified, and that's the height property. This is clearly being done by JavaScript, but how can we investigate? Well, using the debugging from the outside in techniques that we learned earlier, as you know we can right click and select break on and choose attributes modifications. So I'll select that, I'll click here, and before anything opens up, we immediately pause thanks to the debugger. We don't particularly need this screencast view, so I'm going to hide it for now, and I'm going to hide that file tree view. I'll open up the console with escape, and we're ready to do some debugging. All we want to do is find out from where that height property was being set. So as you can see we get the call stack, and there's a lot of jQuery here, so I'm going to go through this, and I see some code coming from main.min.js, but this is all minified and I don't really want to look at this, so we can pretty print that. And as you can see the source files that are being referenced here are slightly different. It's got the formatted word in there, so that should help us. Here I am at this onToggleRequest method in the call stack, and as you can see we have this.mobile container. I'm going to select that portion, right click and evaluate in console. I'll use $_ to reference that last variable and see what available methods there are. Off the bat this kind of looks like a jQuery object, so it kind of makes sense what's happening now. On this .mobile container, which is that DOM element that we broke on, it's setting a height, and the height in question is 472. I'll resume script execution, go back to the elements panel, and we can see indeed the height was 472 pixels. So what's the point of all this? Well, it goes to show that even in something on a mobile device, where in the past these could have been very tricky to debug, that was all really straightforward and better yet really convenient. Another huge benefit, which is pretty important to mention when doing remote debugging, is all the performance metrics you collect are actually going to be directly from the device, and this is huge. So what I'll do is I'll start a timeline recording, start scrolling, and you can immediately see that these bars are pretty populated. If I was doing this on my desktop, they probably wouldn't be as full because, well, my machine is fairly powerful. And we can go into these bars just like you would expect. And we can see right here that there's this massive paint, and if we click through we even get the elements in question. Don't forget we can even click on these elements to find out what node in question caused such a record to occur. You might find it really helpful to integrate this into your regular development workflow to make sure that you're collecting performance metrics as you go on. We can also see this little warning icon which we covered earlier when looking at the timeline panel. We can drill into that and we get all these reasons for why a style calculation was forced. As you can probably guess, it's pretty important to collect a network trace directly from the device because this will give you a much more accurate representation of what your users might experience. So I'm going to clear this and hit Command R. The page reloads, and I'm going to hide the screencast since we don't need it. And as you can see, 4 seconds, okay, that's not too bad. But there's something really important to take note of here, and that's the status column. There's a lot of 304 not modifieds, and this is risky because we don't want to rely on these stats too much as we have a lot of items in our cache. Let's disable the cache, clear, and Command R again. And now, as you can see, there are a ton of resources being downloaded. That's 76 requests and almost 5 megabytes of data being downloaded. If we sort by size, we might be unsurprised to learn that the biggest culprits are images. It would definitely be worth putting these through a tool like Image Optim or Image Alpha to try and optimize it. Let's do a quick recap. I will close this. So with a page open, you can open up the developer tools, and after enabling the devices pane, you can click on this devices icon, or you can hit the escape key and you'll see it right there. Or try and connect to your device, and as long as you've got developer mode turned on, you can click try here. A brand new DevTools will open up, and this will be the DevTools that is connected directly to the page on Chrome for Android. You can click the screencasting icon and control your device right here, or as I'm doing right now, you can scroll it on the device and it will be reflected here. Inspect element works just as you would expect. Select the magnifying icon, select images, and that just works. It's almost always worth collecting network traces and timeline recordings because you'll get a much more accurate representation as to what your users might be experiencing. Thanks for watching, I'll catch you in the next lesson.